Welcome back students. This video is for class 8, chapter number 13, sound, page number 159. Chapter number 13, sound, page number 159, class 8, physics. Okay, it is the first part of the video and chapter. Now the name is sound. Okay, so basically when we hear the word sound, okay, so what comes to our mind first? Sound means music, right? Sound means something which we can hear. Okay, so we recognize sound by our eyes. Now sound is also a form of energy which travels in the form of vibrations through air or another medium. Vibrations means what? You might have seen the guitar string. Okay, you might have seen the guitar string. So when we pluck the string, what happens? It vibrates, and due to that vibration we can hear the sound. Similarly, if we are playing tabla, okay, while playing tabla, what happens? The what we can say, the what that circle of the tabla, when we bang on it, there the vibration takes place, and due to that vibrations we can hear a type of sound. Okay, so sound is a form of energy which comes due to the vibration of any substance or object, and it travels through the medium called as air, right? Normally in our surrounding air is present and we hear the sound, so that sound travels from the air. Okay, next, now they have given us some example of sound, that is pleasant bird calls. Means the what we can say, the singing of the bird. Okay, when the bird sings, or music, or the unpleasant noise of horns, vehicle horn. So all these are examples of sound. Okay, so the thing which is the sound which is pleasant we call it as sound, but the with the unpleasant or the disturbance is called as noise. It is called as noise, and these are the different sources of sound. Now how is sound produced? For that they have conducted an activity. Now here you can see there is a table, which is activity 13.1. so there is a table, a plastic ruler is placed. Now what happens? They have holded that ruler with one hand, and with the other hand they are just plucking it, and due to what happens, the ruler vibrates. Now again, due to that vibration, some sound is produced. Second, if you take a rubber band, just attach it at two ends and then pluck it, what you will see? You will see some vibration, this kind of vibrations, and this vibrations also produces sound. Next is this tuning fork. Tuning fork means, now you don't know, you might not have seen the tuning fork, but imagine means a tongue like structure. Okay, so what happens if you just pluck it? The two ends vibrates, and this vibration produces sound. Now if this vibrating fork, I immerse it in water. Okay, if I immerse it in water, you will see the water also starts vibrating. Means the vibration can be transferred from one medium to another. Okay, next what they say. Okay, so the vibrations are rapid and we cannot observe them distinctly, right? We cannot count them, they are in a rapid state. Next, however, with the help of simple pendulum. Now pendulum, you might have studied about it or not, but let me explain you. Okay, if you take a thread, means imagine a thread and a iron or metal bob. Okay, any metal circular body is hanged over to the or tied to the thread, and if you fix this end of the thread to some surface, and if you take this bob here and you will leave it, what will happen? It will go here, again it will come here, it will go come. So this type of thing is called as oscillation. Means if you take this bob here, here, okay, if it is taken here and if you leave it, what will happen? It will travel some distance, it will go here, and after that again it will come back. So this from coming from means going one and coming back, this is called as one oscillation. It is called as one oscillation. That is means going from here and again coming back to here. Means the whole process from to go and come, is known as one oscillation. So we can observe this type of thing in pendulum. Okay, so this is called to and fro movements. This to and fro movement, this is called as oscillation. Next, characteristics of vibration. Now if you imagine the sound in the form of wave, okay, so wave has some characteristics, so we are going to study about these characteristics of the wave. So what they say, the three important characteristics of vibration are amplitude, frequency and time period. We are going to study about it, but just at the start or at the beginning, just remember this name: amplitude, frequency and time period. Okay, now what is amplitude? Amplitude means what? Now if this is a wave, okay, if I say the means if some sound is traveling in the form of wave, okay, let us consider any sound is traveling in the form of wave. Okay, so if this is traveling in the form of this type of wave, okay, this is, suppose this is a wave. Okay, this is a wave. Now what will happen? Now to study amplitude. Okay, so what is amplitude? If this is a wave, so the maximum distance, okay, now wave, why wave? Because if the body is vibrating or it is oscillating, okay, it will oscillate in the form of wave. Means this will be not in the form of wave but the vibrations, okay, so the readings of them will be in the form of wave. Now the maximum place where the vibration has taken place, okay, from its mean position, mean or this zero position to here, so if we call it as A, so from this O to A is called as amplitude. It is called as amplitude. So the maximum displacement is amplitude. So what they say, the maximum extent of vibration of a vibrating body from its mean position, so that is CD is the amplitude of vibration. CD is amplitude of vibration. Next is frequency. So number of vibration experienced by a vibrating body in 1 second. Now if this wave, okay, if this wave is taking 1 second to complete, okay, means from here to here, if a particle takes 1 second to reach from here to here, okay, so this is what the frequency. Okay, so the displacement in 1 second is called as frequency, okay, so I repeat, amplitude means what? Amplitude means maximum displacement. Amplitude means the maximum displacement, whereas frequency means distance travel in 1 second, that is frequency. Okay, so the number of vibrations means if one wave takes 1 second, then it is frequency. Okay, suppose if this wave, means now in 1 second the one wave is getting completed, okay, if two waves gets completed in 1 second, then to the frequency will be 2 waves. Okay, now here the frequency is 1, so number of that vibrations in 1 second is called as frequency. Next is time period. Now time taken by the vibrating body to complete one vibration as its time period. Now to complete this, now the difference between frequency and time period is, now you can see here time period. Okay, now what was frequency? Frequency means number of vibrations in 1 second, okay, displacement in 1 second. But time period means what? The time taken by one wave to get completed. Okay, means here the time was fixed, was 1 second, but here the time is not fixed. Here what they are saying, the time taken by one wave to get completed. Okay, so time for one wave or one vibration is called as time period. Okay, for one thing, the time required for one things to get completed is called time period, and number of waves getting completed in 1 second is called as frequency. And the relation between frequency and time period is f is 1 by t. It is f is small. Okay, so frequency, the relation between this is frequency is 1 by time, because you can see this, they are opposite of each other. Means what? The frequency means what? Number of waves in 1 second, and time period means what? The time taken by one wave, means they are opposite of each other. So f is 1 by t, frequency is 1 by t. Clear? So this is the relation between frequency and time period. Now yeah, characteristics of sound. Now as the word sound is there, now it will have some characteristics, right? Means what? Loudness, amplitude of vibration. It is having different types of characteristics, so we will go through them one by one. Now major qualities are loudness, pitch and quality. Okay, loudness means what? You can means imagine the word loudness. Okay, loudness means something which is which is unpleasant to our ears, right? Means if volume of something is very high, we call it as loud. So loudness means something which has very high sound. Okay, so sound can be loud or soft if the string of a guitar is plucked gently, right? The sound can be pleasant or unpleasant, depends upon the energy which we have given to the string of the guitar. If it is plucked softly, what will happen? You will get a soft sound, but if it is plucked means hardly, you will get a hard sound. So if it's plucked harder, a louder sound is produced. And loudness depends upon following three factors and depends upon three things. First, amplitude of vibration. Now you can see here, means amplitude is what? The distance, right? Now the maximum number, the maximum distance. So we can say that when the amplitude is maximum, right, when the amplitude is greater, the loudness is more, right? A vibration carrying more energy produces a louder sound. So means what? A vibration with more energy, if this the distance is more. Okay, means you have a big wave, means what? It is the wave of a loud sound. So a vibration carrying more energy produces a louder sound. Such a vibration or wave has a larger amplitude, it will have a larger amplitude. Next, loudness is proportional to the square of the amplitude. Now again there is a relation between, as there is a relation between frequency and time period, here is a relation between amplitude and loudness. So loudness is proportional to the square of amplitude. So we can say that, we can means write a formula like loudness is proportional to square of amplitude, right? What it is saying, loudness is proportional to square of amplitude. So this is the sign of proportionality. So loudness is L proportional to amplitude square. If the amplitude increases 3 times, the loudness will also increase 3 times, right? So what will happen? This, if loudness is considered as 3, okay, if this is considered as 3, so proportionality, A will become 3 square, so it will become 3 is proportional to 9. Means if loudness is 3 times, you will get amplitude as 9. Clear? So this is the relation. Next is area of vibrating body. The greater the area of vibrating surface, the louder the sound. Big drum produces a louder sound than a small drum. You might have observed, if you take a big drum, what will happen? If you bang it, you will hear a loud sound. Comparatively, if you take a small drum and if you bang it, you will hear a soft sound or low sound. So the greater the area of vibrating surface, the louder the sound produced. Next, distance of listener from source of sound. Now distance also matters. If you go near the speaker, okay, if you go near the speaker, you will hear a loud sound, but if you go away from the speaker, you will hear a low sound. Similarly, nearer the source, now source is speaker, okay, because it is emitting the sound waves. So the source is speaker. So the nearer the source, the louder the sound we hear. And sound wave lose energy as they travel. So the further away we are from the source, the softer the sound we hear. Clear? Next, pitch. Pitch denotes the shrillness or flatness of the sound. Now what is pitch? To understand pitch, pitch means the softness or means the flatness of the sound. Okay, the sound can be high pitched or low pitched. It is of two types. The pitch of the voices of women and children is higher. It is said that the women's and children's uh, voice pitch is higher compared to the man. Now to understand pitch, when you whistle, right, when you whistle with the using a whistle, okay, proper whistle, so you can hear a like that means pricking sound in your ears. That is actually the pitch. Okay, so a whistle makes a high pitch, and you can see that the drum do not, it means pricks into your ear. When you bang a drum, it do not pricks inside the ear, but a whistle does. So that pricking something is pitch. So drum do not have a pitch compared to the whistle has. Okay, whistle has a high pitch. Next is yeah, the pitch of a sound depends on the frequency. Now if you whistle more and more times, what will happen, it will create that irritating sounds a lot. So that pitch depends upon the frequency. Frequency means number of times. If you are means doing it what we can say repeatedly, to the if the frequency is high, the sound is high, right? A sound having a frequency of 512 hertz has a higher pitch than the sound having 256 hertz. Means if the frequency is higher, the pitch is high. Similarly, the position of a sound on a musical scale is related to its pitch. So the position, now you know these notes, right, on that instrument called as piano or peti, right, harmonium. So there are notes that like sa, re, ga, ma, pa, dha, ni, and again sa, right, sa, re, ga, ma, pa, dha, ni. Now in this, while you play that, you can hear that ni has that long pitch. Okay, so if you don't have, you can see, you can hear it on YouTube. Okay, so once the video is finished, go for it on the YouTube. You can hear that knee has a long, that pitch like sound. So means it means when you hear it now, you will understand it better. Okay, so that knee has that higher wala sound, and each note has a higher frequency than the one before it. Means sa will have lower frequency, re will have greater than sa, ga will have greater than re, ma will have greater than ga, pa will have greater than ma, dha will have greater than pa, and ni will have greater than dha. Means ni will have higher of all those. And in Western music, they are, in Indian music or classical music, they are called as sa, re, ga, ma, pa, dha, ni, and in Western music they are called as do, re, mi, fa, so, la, and ti. Okay, so these are the notes. Next, quality. The two notes of the same pitch and loudness can sound different. Now depending upon the instrument, okay, means if you play that sa on harmonium, you will hear it different, and if you play that same sa note on a flute, you will hear it in a different way. So the quality of the sound depends upon the instrument you are using. Means you won't hear the sa as same as on harmonium, on guitar, on flute. Means on different instrument you will hear a different sound quality for the same note. Understood? So quality of sound is a property of virtue by of which two sounds of the same pitch and loudness can be distinguished. Now next is musical sounds and noise. Now sound can be classified as musical sound or noise. Okay, means the sound is first, as I said, the pleasant one is music, and the one which disturbs or one which is irritating is called as noise, right? So it is classified as two, that is musical sound and noise. Now the sound produced by a tuning fork, violin, veena, and piano are called musical sound, because they, from this we can create a music, but they are produced by vibration that are regular and periodic. Now on the other hand, certain sounds such as thunder, rattling of wheels on a rough road, large number of people talking at the same time inside a room, are produced by regular non-periodic vibration, and they are called noise. Now as you can see, when you hear a song, right, the beats and the music is in a uniform manner, right? You won't hear that different things are means getting mixed up and you are hearing something else. No, it will have a perfect pattern, so that is periodic. Hence so such type of music is called sound. But when for that, best example is in classroom, when many of the students talk at the same time, they speak at the same time, what that happens, it creates noise, right? Means you won't understand anything, means you won't understand anything of a single person also, but then to lots of persons are speaking at that time in that classroom. So such thing is called as noise, which is irritating and which we can't distinguish, and which do not have a pattern, means anyone is yelling in any way, so that is called as noise. Next is musical instruments. So musical instruments are use the vibrations of different kinds of materials to produce sound. Okay, now the in musical instruments you can see that in guitar there are stretched strings, like the strings are stretched one. Next, the stretched membranes, it is found in tabla and yeah, tabla and that dhol drum. Okay, so on that you can see that the stretch membrane means the upper layer is stretched from all the ends, so that is stretch membrane. And air columns, you find this in flute, right? Air columns. Next, accordingly they are classified into three types. Now using these three stretch strings, membrane and air column, they are classified. So first is string instruments. Now string instrument will include, these instruments use vibration in stretch metal wires, which will have stretch metal wire, as in guitar. If this is a guitar, okay, if this is a guitar, okay, you will see the strings, okay, you will see the strings means the wires are stretched, the wires are, so you will see the wires are stretched from one end to another end. Such instruments are called as stretch string instruments, right? And the frequency of vibration is varied by changing the thickness, tightness and length of the string. Means if the string is thick, you will get a that harder sound, right? Depend, if the string is thin, you will get a soft sound. So depending upon the thickness of the string, you will hear the different types of sound. And the examples are sitar, guitar, violin, sarod and veena. So these are the examples of stretch string instrument. In this, a thin string has a higher frequency than a thick string of the same length and metal. Now it will have a higher frequency. Now higher frequency means what? Now if the string is thin, okay, if the string is thin, what will happen? If you pluck it, it will make number of vibrations more. Okay, means it will, suppose in 1 second it will make 100 vibrations because it is a thin one. If you take a thick string, means if the thick string is thick like this, and if you pluck it, it might make only 40 or to 50 that vibrations in 1 second. Means this thin one is making 100, whereas the thick one is making 50. So it is saying that thin string has a higher frequency. Higher frequency means the number of vibrations in given time is more. A short string has a higher frequency than a long string of the same thickness. Now if this much is the string, what will happen? If I pluck it, it will vibrate more. Comparatively, the long one will vibrate less. So the short string has a higher frequency and the long string has a lower. The more taut the string is, the higher the frequency of the sound. If the string is loose, it won't vibrate that much. But if the string is enough tight, what will happen? It will vibrate more. So taut means that tight, okay, it has those screws to make the string tight. So the more taut the string, the higher the frequency of the sound it produced. Okay, next is percussion instruments. So many percussion instruments are vibrate out of a stretch membrane. Stretch membrane means, now here it is tabla. On this you can see that the upper layer, that is known as membrane, and it is stretched from all the side. You can see that. Now here in this mridang mridangam, you can see that the membrane is again stretched from all the ends. So if the membrane is not stretched, it is loose, what will happen? You won't able to produce the music. But if it's stretched enough and if you bang it, you will hear a music or a pattern of music, right? Now to make this membrane, the often animal hide, means animal skin is used. Okay, animal skin is used to make this membrane. The frequency of vibration can be increased by stretching the membrane. More tight the membrane is, the more frequency of vibration will be seen. And the tabla, drum and mridangam are examples of percussion instruments. Clear? Now next is wind instruments. The instruments use vibrations in air columns. Now wind means, you can imagine, right, in flute is hollow. Have you seen a flute is hollow from inside. Okay, so it has holes, and one end it is closed, from where you can play it. So these instruments use vibration in air column. Air column means it will have a hollow place from where the air can travel, and using that you can play a music. So the frequency is varied by changing the length of vibrating air column. If the air column is short, means if the size of flute is short, you will hear a different music. If the size of flute is long, you will hear a different music. So depending upon the air column, the frequency varies. Okay, so in wind instrument, a short air column produces a shrill note of higher frequency than long air column. The flute, shehnai and clarinet are some examples. Okay, and the harmonium, mouth organ and nandaswaram are also some examples. So they have given the examples of the instruments. Okay, so with this let's stop here. In next lecture we will go for how sound travels and remaining chapter. Okay.